All right, so what I was just saying is second derivative of a function is easily, they'll call that twice differentiable. Okay, so here's what this second derivative test says. It says if f prime of c is equal to 0, what does that mean we have? This is a crit point. Every single one of these is talking about a critical value. So I found a critical value already. And notice that I did not say if it's non-differentiable. I'm being very specific here. This is f double prime of c has to equal 0 for this. If it's non-differentiable there, then how could there be a second derivative? And f double prime of c is greater than 0. What does that tell me about my function? I have a concave up function. So real quick, draw a curve that is concave up. A parabola that opens up. I have a concave up graph. Where's the critical value of this graph? At the bottom. F of c is a relative minimum. F double prime of c is equal to 0. Our f prime of c is equal to 0. F double prime of c is less than 0, which means we have a concave down graph. I have a function that's concave down. What does that tell you? It tells you that our point is A. And then my personal favorite. The first derivative equals 0. The second derivative equals 0. Then the second derivative test was completely useless, and you found the second derivative for no actual reason. Woo! Those are my favorite. I guarantee you that came through. Like calculus. All right. Why would the first derivative work? Typically, when you get a situation where the concavity is equal to 0, we'll either have some sort of line, or we'll get some situation where you'll curve up and then still increase. The problem is in this particular setup, it doesn't. Whereas the first derivative test is if my function goes from increasing to increasing, there's no way that point can be a relative max. This doesn't necessarily guarantee that there's not a relative max there. This is just saying, well, the concavity flattened out. But what if the concavity equaled 0, it was concave down to the left, hit a concavity of 0, and then continued to be concave down? Well, at that spot, we're not sure what the concavity is, so we can't really guarantee its concavity. All right, I'm going to skip this one right here. Last period got that one, so if you want to know what the answer to that is, we'll find out. Let's talk about the trig question. I tell you that I have an f of x equals negative 2 cosine x minus x. I'm going to use the second derivative test, so I don't have a choice. I've got to use the second derivative test to find whether f has a local max or a local min at x is equal to pi over 6. So this is how the second derivative test works. First off, I have to prove two things. I have to prove f prime of x is equal to, or f prime of c rather, is equal to 0. Have to prove that. After I prove that, I have to prove the sign of what f double prime is. Once I've proven what that sign is, I can come up with my conclusion. So, f prime of x. What is the derivative of negative 2 cosine x? 2 sine x minus 1. Normally I would set this equal to 0. Notice what the question is asking. It's asking, is there a relative max or min here at x equals pi sixths? I'm just going to evaluate f prime of pi sixths. If this works, great. If it doesn't work, if this equals 0, I'm in business. If this doesn't equal 0, I'm done. I probably messed up somewhere. Sine of pi sixths is 1/2 times 2. 1 minus 1. 2 halves. 0. So the first derivative is 0. So now I need to find the second derivative of x. What is the second derivative of x? Cool. So f double prime of pi sixths equals, you're going to enjoy this, 2 cosine of pi 6th. Y'all ready for this? Y'all ready for this? Cosine of pi 6 is in the first quadrant, which makes it positive. A positive times a positive is still definitely a. I don't care what the number is. I just need to know that it's greater than 0. It is the square root of 3. So if you really feel the need to write that down, then you win. If you don't feel the need to write that down, then you're a bigger winner. All right. So is this a relative max or relative min? This is a concave up function, so this should be a relative min at x is equal to pi 6. We have to justify, so we say since, what were the two things I had to prove? F prime of pi 6 is 0 and F double prime of pi 6 is greater than 0. Done. That's the minimum amount that you need to write in order to be able to get this answer. You could say and F is concave up since this is here. Well, for some people, they have a hard time. They have to think about the concavity before they come up with the answer. Okay? So if you needed to go through the step of this is concave up, okay, this has to be at the bottom of the function, and you want to incorporate that, is that acceptable? Sure. Is it required? Absolutely not. Another thing we can do, use the second derivative test to find relative extrema. Now notice this is different than the problem we just did above. In the previous question, I told you the exact x value I wanted you to test. In this problem, I don't have this. I'm also going to tell you, I would normally not choose the second derivative test for this question. But I'm going to make you do it because it's a nice, easy problem. Yay! All right, to do the second derivative test, I do the f prime of x, which is I need to set this equal to 0 because I need to find out when does f prime of x even equal 0. I need to find those values. So I factor out a 6. I call this x, I believe it'll be plus 2 minus 2. Or minus 1, sorry. Double check that. If I factor out the 6, I get x squared plus x minus 2. So that should work. And my critical values are x is equal to negative 2 and x is equal to 1. Now normally, if this were me on any normal problem, I would have already drawn the line graph. I would have put pluses and minuses, and I would be answering that way. But I told you that I had to use the second derivative test, so I'm going to do that now. Second derivative test says find the second derivative. No. Yeah, we don't want to set 12x plus 6 equal to 0. We want to now, we've got f double prime of x. For second derivative test, I just need to know at that point, does this function have positive concavity or negative concavity? So I go through and I go f double prime of negative 2, which is 12 times negative 2 plus 6. 12 times negative 2 plus 6, positive or negative? Definitely a negative value. F double prime of 1 is 12 times 1 plus 6, which is definitely a positive value. All right. We're not done yet. Be very careful. Do not make the following statement. Relative, see that's concave down, relative max at x equals negative 2. Do not make that statement. Why? Read the question carefully. Find the relative extrema. I want to know the actual max and the actual min. What I do not want to know is where the max and min are. Now I got to plug them back in. So I have to find f of negative 2, which is 6 times negative 2 squared. Nope, wrong statement. Also be really careful at this point. Did anybody catch what I just did? Plugged it into f prime. Don't be silly. So this is 2, 4, 8. This is negative 16. This is positive 12. This is positive 24. 12 plus 24 is 36. Minus 16 is 20. So is that a relative max or relative min? This is from negative 2. At negative 2, we said the concavity was down, so this is a... So actually, I tell you what I'm going to do. I'm going to hold off on making my final statement, but just know that this one right here is your relative max. I also need to find the f of 1, which is a whole lot easier than the last question we just did, which is 2 plus 2... No, 2 plus 3. I can't math. 2 plus 3 minus 12 is negative 7. That is my... Okay, how am I going to write my defense here? My justification. Let's say the relative max is 20 since f prime of negative 2 equals 0 and f double prime of negative 2 is negative. I'm going to say a relative min is since the importance of this is not necessarily the process. The process is quite repetitive. It is very much a process. The importance that I want is the justification. I need to see that f prime equals 0 at the x value, at the c value. I need to see the sign for the f double prime of c. You have to state that. The other thing I want to point out is this is different than most of the other problems we've done where we've said the relative min is at or the relative max is at. This is relative min is a number. Relative max is a number. All right? Good. So, how do they force you to do the second derivative test? Because clearly, like I said just a second ago, I said in that problem I would use first derivative test. This is an example of how they force you to use the second derivative test. What they do is they give you some weird function. And usually that function is described by some really screwed up generic function that they only give me a single data point for. Because they gave me a single data point, there is absolutely no way for me to be able to tell you whether this function changes from increasing to decreasing, positive to negative. I have no clue what g of x is going to do in this problem. Except when I'm looking at g of 3, which is definitely negative 2, and at g of 3, the derivative is definitely equal to 7. That's what they've given me. So now what?